All right, co-requisite material lesson number 4. This should be one of the simpler, I guess, material content leading up to the statistics part because we're getting into confidence intervals. And so anyway, I think it's worth our while to kind of step back and review operations on fractions. Remember, if we're adding fractions, we need to get a least common denominator, create equivalent fractions, and then add the numerators. And as I've done out to the right, uh, reduce the fractions and write it as a mixed fraction sometimes. We typically in mathematics leave fractions in this form at this level. Subtraction, same thing, create equivalent fractions. Take the numerators, 5 minus 3 gives us negative 2 over 6, reduced to negative 1/3. Multiplying is probably the easiest operation on fractions. We multiply the denominators, multiply the numerators. So we get 1 times 5 and 2 times 6, which is 5/12, which is in simplest form. Just to jog the memory a little bit, if we're dividing fractions, remember we invert and multiply. So we take 1/2, invert, multiply. So instead of 5/6, we multiply by 6/5. We get the fraction 16 again. Multiply the numerators, multiply the denominators. You can actually cancel, reduce the 6 over 2 to 1 over 3 to get 3/5 right here, or you can just multiply it out and reduce later. Interval notation is extremely important in learning confidence intervals. So just as a kind of a jog to the memory, remember if we're looking at the interval from 14 to 35, that on the number line we're looking at the set from 14 to 35, but not including 14 and 35. And this is equivalent to in interval notation, in inequality notation is 14 less than x, and x is less than 35. Now we need to find we need to be able to find the center and the width of the interval. And to find the center of an interval, it's really easy. We just take the endpoints and add them and divide by 2. In other words, we just average those. So in this case, 14 plus 35, which are the two endpoints, is 49 divided by 2, which gives us a center of 24.5. And if we want the width of the interval, we just take the high number minus the small number. Now, this is not to be confused with something we'll call margin of error as we get into the statistics content in this lesson. The margin of error is actually the big number minus the small number divided by 2. So the margin of error for this interval would actually be 10.5. And that's something we use a lot in describing intervals. We get into more complex expressions in this lesson. So I've demonstrated this. So what I would do is by substitution, z squared, z is 3.1, so I'm going to write 3.1 squared. P is 0.91, so I wrote it. 1 minus p is 1 minus 0.91, and then in the bottom I would take e squared, which is 0.03 squared. So in the denominator we get 0.03 squared. Before I start entering things in my calculator, I would start simplifying. The only thing I need to simplify here is instead of 1 minus 0.91, which can be a challenge for some people to enter in their calculator, I would just change that to 0.09. Now, once you get there, and I've already done this in the calculator just to save a little bit of time, you can see that please excuse my dear Aunt Sally just kind of takes effect and is addressed in the calculator. So I'm not adding or subtracting anything, so I don't need to worry about parentheses. Everything is done from left to right. So square 3.1, multiply by 0.91, multiply by 0.09, and then divide by 0.03 squared. to get 874.51. Now, in this context where we're just learning to evaluate expressions, we would leave this at 874.5 or 874.51, depending on how we were asked to round. But in the context of statistics, this problem being in a statistics problem, n is our sample size, we can't have 874.51 dogs or cats or trees or students. So we would always round this up. So the answer would be 875 in the context of statistics. The context of evaluating this complex expression, we could leave it at 874.51 again, but I hate to be redundant here, but it's important. In the context of solving for a sample size, then we can't have 0.51 of a case. And it turns out you always round up here. So if this was 874.05, you would still round up to 875. So just tattoo that one to the brain. That's all I got.